Welcome everyone to our benchmarking week here on our open source channel and our Linux distribution. And the last days I massively benchmarked stuff just to reason with reality and see what latest and greatest developments GCC and Clang had in store. And of course the comments, right, I benchmark Stack Smashing Protector for security and position independent executables and auto var initialization stuff just to see how much performance we lose, and then all the massive optimization variants from 1 over S and 3 and fast and x86 ISA micro architecture variants there of the new version 1, 2, 3, 4 and so on, and native. And people of course rightfully but profile guided optimizations. So I did that, but only a little, and I burned way too much time on this. You would think you benchmark here like a dozen of variants and like profile guided optimizations. Of course, I knew them for a long time, I used them, but if you just apply to some random packages like that failing, that strange results, and like, yeah, way more than 1 hour, easily 2 hours just for like 2 lines of benchmarking data. Before we take a look at this, I don't even have that much to show. I theoretically have even still stuff running, so massive code shuffling there in our open bench scripting stuff for profile guided optimizations. So what is that, right? Normal optimizations, you give the compiler code, C or C++, Go, Rust, and so on, and the compiler builds their code flow graphs and so on, code flow, and then eventually generates assembly and so on. And in all those optimizations, the compiler guesses, does some static analysis, whether branches will be taken, how often loops are run and stuff. And that is of course not the real world. It should be somewhat okayish, but yeah, that is where profile guided optimizations, just your next best summary, just because. And what that does is you, instead of building it once, you build your stuff twice, once with instrumentation for this profile guided optimizations. Then you run this stuff on some test suite. Also, pro tip, if you have a test suite, right? Not some other YouTubers like, they don't like test suites. No, test suites are amazing, and also for profile guided optimizations. And then using this profile, so what this does is when you run your test suite or other benchmark stuff, then this instrumented code, of course, is super slow, but stores some coverage data of which functions are used, how frequent, which variables are accessed for register allocations, like which frequently used variables to keep in registers and which to spill back to memory, and even do code block sorting. And so as you see, so it sounds super simple, right? Just like, is it for like build, like instrument, profile, optimize, 3. The devil is in the detail, right? It is as simple as running f profile generate some directory. Yes, there are some other options, but that is the most simple. Of course, yeah, one-liner program, right? Hello world, like, yeah, good luck. And then you run this, your program name there, and then you use this profile, use this directory of what you've just run. Of course, in a real project, you need to make clean and rebuild the stuff, but there's also the devil in the detail, right? So simple. So that function inlining, as I mentioned, frequent use of function, where, like, for example, the compiler might think, hey, this is small, it's inlined, but it's never used, so then it's not even a benefit, right? Or a function is huge and GCC static analyzes, yeah, it's too big for inlining, but it's like constantly used and stuff. So this is where the profile guided optimization comes in. Block ordering, right, the right term, just didn't came to my mind. Like building a control flow, and then like, yeah, this is not how it's most often used, with like functions calling other functions, and register allocations, as I mentioned, and like, of course, with T2 Linux. Let's maybe take, so this is how this works. It sounds simple, but it's at times a pain to use. If you have your own project, like I have my exact image or other stuff, of course, it's relatively easy. You just have your setup, you run your test suite and stuff. It's relatively easy. But if you, even in my benchmark here, I use just a handful of common stuff. It's like, yeah, this stuff breaking left and right for stupid reasons and so on. But if you take a look at the comments, at the results, I've done here two things. I've done here O2 native, because I thought that is what people often use. That should be somewhere. Where is O2 native? PGO. I abbreviated the stuff, right, because this is already too much data and too much text. So PGO stands for F profile use and stuff, obviously. And if we compare this here, we need to be a little bit careful, because we have here also Klingon the time. Also, some results might not yet fully be ready. And also there are some, also I guess this libmat did not run correctly, despite I fixed like Lua and set standard and stuff, but more to that in a second. So if we look at the most, this is not even the most impressive, maybe I mean, some stuff is a little bit faster, like set standard, right, 728 to 7. And here, whatever that was, Lua. All right, Lua benefits quite a bit. That is from 0.53 to 0.50. Here, this is probably the not correctly used stuff. Then this is also tiny a little bit. So it's not even the biggest stuff, right? This might not be the final result. I was still tinkering around. More impressive here is then I thought, okay, let's throw everything on, right? Oh, fast. PGO, like profile, like, because you always ask what is the best, right? Let's throw everything on it. So yeah, we don't have a result there, more to come, but fast native profile guided optimizations, LTO whole program, like just freaking, like how much epic thread ripping CPU cycles can we spend on this problem? Let's just overkill optimize the heck out of it. And there it becomes a little bit more impressive. We need to, like, at least comparing that here to fast native with all this stuff. The most impressive is Lua in this run here, 0.56 to 0.41. That is a whopping, like, in total, not profile guide optimizations alone, but in total, I think, what did I title that? 27% faster. Then 7% faster is, I think, GCP. Also, yeah, that was 7% faster. So there you see also, right, recurring theme for math formula, matrix multiplication or other 3D stuff, the benefits might be better. But on relatively, I mean, you could always argue, but my code is different, right? Sure, I include here Lua for some scripting stuff, Lua because it's way more simple than Python and stuff, and obviously used in Adobe Lightroom and lots of games. I used the set standard for latest and greatest C standard quality code for latest and greatest compression, JPEG somewhat, which probably, yeah, there still has some implementation marginalities. Also, as you see here in this native versus PGO, it wasn't even faster. Yeah, I have to say, for me, it's probably not worth it, right? For the whole open source Linux stuff, as everyone builds their stuff at home, it's probably not worth it. For me, I wasted 2 hours for not even the best YouTube content. I wish I could say, like, it's amazing. It's like, maybe I need to add some. Probably next I add some sophisticated C++ stuff and then epic thread through all the stuff. So even for me, with the Linux distribution, right, huge complications. I can't even just simply use it in our T2 Linux because we cross-compile most stuff, right? And then I can't use this profile guided runs unless I run them through QEMU. And then yeah, I mean, it's probably somewhat accurate, obviously. Yeah, it probably actually should be quite the same through QEMU. Another way would be, theoretically, other distributions could do that because they build natively on like for weeks and months, I heard. T2, of course, one of the most cross-compiling general purpose desktop and server and certainly embedded distributions. What I theoretically could do is, if I wanted to, I could build x86-64 cross-compile, but I can natively run that. Store that profile guided optimization. So theoretically we could run, it's a massive amount of work to wire up test suite profile guided runs for each package. Theoretically it's doable, often stuff has a test suite, but yeah. We could do that, keep this profile guided data like in our build direction, like build shared profile guided optimization, build x86-64 first, and then everything else using the same profile data. That is not, it probably would need some hacks. That is not how the GCC people would have engineered it to work. I'm not even sure if it would just work because this stuff is checksummed. And so if you run the stuff altered, it will not use this profile information. GCC will error out with like either no profile data for this file, or it that is a warning, or it will error out like profile generated with another configuration stuff. Even changing optimization settings, right? It will not use the profile data if it's just somewhat a little bit different, for sanity reasons, not to use like totally different code of different includes, different glibc, different GCC. This will not match anymore. So the profile data needs to match quite closely. I'm not sure if it would just work. Maybe I would need to patch GCC. I have not tried that. It might be that due to config hash values in their hashing, the architecture, who knows what. It probably could be done. It might not be pretty. Also, it's probably not accurate, obviously, because at least some information, I would think most stuff should match quite well. Probably should help more than regress, but you never know until you try. But the biggest problem is endiness, so profile data could be even vastly wrong if code checks for endiness think MP3 data, that might be big endian or so. Most file formats, actually most of the time big endian. So your profile data from a little endian AMD64 profile run might, even if you hack this up to load and use it and stuff, the profile data might be off in architecture specific situations like endianness. It should not be that often. Theoretically, even like 32 versus 64-bit, not even sure if GCC would error out significantly of this hash of whatever types and whatnot. Not sure if I've not looked into the implementation detail, if they just hash the options and architecture, I don't know, or if they hash just the source file, who knows, whatever. I'm only saying here some stuff, right? Might be possible. It is a lot of work for sometimes a little bit benefit. And this stuff, last but not least, let me tell you some tale of, oh, by the way, did this just finish apparently, maybe? Let's check. So yeah, I still need to check what's going on with libmet. I think there's also this GPG also runs forever. That is probably the profile run, because yeah, this is so long. So this stuff, there are some caveats, right? So first is some code runs forever with, I even Control-C that. You see GNU, and when you wonder, why does this crazy YouTuber with his tiny little Linux distribution, why is he benchmarking this with, why is he not using Apache, MySQL, what is this other VM, or Node.js or Firefox? Like, yeah, I don't want to build this stuff for 10 minutes, right? Or 15 on an Epic Threadripping Ryzen 56. I want this stuff to build in minutes, not tens of minutes. And I want to have result in minutes and not in hours. This is why I'm using this and usually it provides some guidance of what we are dealing with. Because here, look, this stupid YouTuber, right, using this tiny tests on his Epic Threadripping stuff, but yeah, with profile guided stuff, it runs 790 seconds, right? 790, that is like 12 minutes or whatever. This is also why I further improved this stuff to not run for profiling. I now have added, and it's like, yeah, how did I spend 2 hours on this stuff? I mean, first of all, dealing with all the stuff, with all the breakage and regressions and stuff, and then also adding some support, because it's just too slow, even on an Epic Threadripping Ryzen 50X, even on some sets and that stuff. It's like, yeah, instead of profiling that for 5 minutes, only profiling that for 40 seconds or stuff, with like only running at once. There are some other issues. The other issue is you cannot just run configure, for example, because configure has the same conf test sources. So initially I just like used my benchmark scripts and run this, and it's like I fired it up and it's like fail. It's like I looked into log files, like, yeah, configure GCC profiling stuff of conf test C different hash whatever something fail assert and load whatever arguments options out of, and so yeah, so you can't reconfigure, at least, I mean, you shouldn't anyway. So I had to add some stuff of specifically removing the profile stuff from configure, because that's also the thing, right? You run this build all the stuff with f profile use, and then configure fails with, yeah, like you run that profile store. What was it? Profile generate, and then you can't even like run all your benchmark with if profile use, because then like configure doesn't even configure, because the C compiler doesn't work, because conf test all profile stuff out of sync and hash. So I had to quirk that, like to configure without that, obviously. And then due to the performance marginalities of waiting, I mean, theoretically, I probably should still optimize GPG, because I don't usually want to wait 700 whatever seconds for some profile stuff. And then the next thing is, what also many people will find, if you either run multi-threaded code, which most of the stuff here intentionally is not multi-threaded to have C compiler and single core general instructions and architecture performance for my CISC versus RISC stuff. But last but not least, what did I want to say? Multi-threaded code, a lot of people will complain like, if you just run this, you will get messages of counters, whatever, whatever, something wrong with counters, whatever that was. That is because multi-threaded code is storing all this counter information, like of all the threads. So all those counted frequencies are out of sync, and like you have like 0 and 1, like you have like 0, 1, it's like interleaving there. And for that, they even have profile correction. It's like, I mean, not only, this is a recurring theme, right? Why is it not even easier to use? But then why are there such heavy gotchas, right? That everyone in a sophisticated application will need to Google why they get error, abort, profile counters, whatever, inconsistent. I think it was, the wording was something probably was inconsistent, like inconsistent counters, whatever. So yeah, you Google that, it's like, yeah, multi-thread stuff, like build it with profile correction. But for me, that happens also, I think at least, because some stuff, it's not really multi-threaded. So I guess you also get this when you run the program multiple times. For example, here with JPEG, which I also, you see, I added here profile instrumentation. Yes, also you had your tiny little readable profiling stuff, benchmarking stuff, and like you need to clutter it with profiling, otherwise you fall asleep while waiting for your Threadripper to Threadrip that. Even here, I mean, previously I've run JPEG decode and encode there multiple times, like 1, 2, 3, 4, apparently times. Is it even? Probably, I guess. And so that's not multi-threaded, but I think the same with this counters, because then you restart your program and you start with this counters from 0. So I guess it's, yeah, if you're GCC developer, leave in the comments below, or otherwise. I think this is exactly the same for like multi-threaded counters, and why. I mean, maybe you should not run this, but I would, I mean, but the problem is if you want to run decode and encode for JPEG like that, you still run probably parts of the compression library for both applications, or yeah. Anyway, I anyway now change this because, again, instead of waiting 5 minutes or 3 minutes for this profiling data to accumulate, it's like, yeah, that obviously is faster. So yeah, this counters, configure, and then last but not least, you need to, for example, why Lua did not build is because Lua did not use the same flags for linking. So the first benchmark, like I run this, the first thing is profile generate and use and stuff, and then Lua even like error looked into the log file and was like, yeah, unresolved symbols or stuff for all the gconf stuff that is in libgconf. So I even had to hack some parts of like freaking hack use, for example, in Lua that is mylibc or stuff, because everyone has their custom make files, right? We can last but not least here live look into, so to summarize that, yes, it can be faster, at least with LTO program. Also, to be fair, I guess, and it's probably an unfair clickbait title, it's probably usually not really even 27%. This 27% here is this fast native versus LTO program optimize the heck out of that. Otherwise, it's probably more, and I probably should also do O3, but yeah, you see how much do you want to benchmark, right? Benchmark this, benchmark that. It's like at the end you have so many benchmarks, and good luck scrolling that. PG also here, it's more like probably here a couple of percent of what is here the best. Yeah, 1, 2, 3, 4. To summarize this, I rather write my microkernel than integrating profile guided optimizations. In T2 we have the smart optimizations for our own profile database on a per file basis of what files are even used in JPEG and ZSAT and stuff. So I rather do that. That is a low-hanging fruit that has quite some effect. I wish this could be more permanently stored. For example, it would be amazing, maybe I should inspire some, like if you're a GCC developer or otherwise, if you are in university and want to have something to do, it would be cool if there could be some like portable profiling printout that could be more long time, that you could ship with your sources and doesn't need to be updated that often and is portable, usable. Probably doesn't include the detail, but instrumenting like branches, likely, unlikely, and that still like function and stuff that still, if you have only light changes between versions, obviously you don't constantly change your files, that it's still, or like function use and variable use that is still like 90% mostly valid even between minor versions. Or even if you like minor versions of your source code editing, or at least if you refresh that, for example, you could refresh this portable profile guided stuff that it has to be invented, and like in your release stuff, make a test suite, store this portable lightweight instrumentation for like at least somewhat for loop frequency, function, variable frequency, likeliness and stuff. It's like, maybe that would be an idea that is more user-friendly, and or I need to invent this myself, potentially, maybe something. Let's take a quick look on, so that was not building, but what that's also, this was libmet, what was even, I mean, this is two things. This is GNU PG fast PGO here. Do we have, what's going on here? Maybe that is actually, you know what, this could be LTO, to be honest. Yeah, that is somehow LTO, who programs have common stuff. Okay, that explains why we don't have a result there. The other that was potentially imperfect is JPEG. Let's see what's going on there. Maybe I should not use some outdated GPG stuff of benchmarking. Why is this still this? Fast PGO, what's going on with that one? Using serial compilation of 4 Ltrans jobs, IDO repair. So that does not look like a build error. It looks actually like this was a successful run. So I would not say it is profile. I would, and I spent already 2 hours on this stuff, right? For not even, that is a thing, right? Maybe I should go to a vintage car restoring and weld there on a rusty Porsche or something, because at least then you know what you have done with your 2 hours. Now you have messed 2 hours with profile guided optimization, and the end result is like, yeah, to be desired. Do I not have that in the log here somewhere? As I'm not the greatest fan of this non-verbal stuff, because now it should be profile guided, profile count, final font. Yeah, so this is to be used. I mean, this is to be expected that some stuff that wasn't used has no profile count there, but that are only some. I think the majority of the main JPEG stuff, Huffman coding and other JPEG coding, decoding, didn't have that warning. So I guess it's only some example programs that we don't even use. Lossless transform support there. So it looks to me that this should be this should build. Maybe that is really again a case where maybe not even profile guided. Maybe that is LTO whole program, and the result is like you ask for LTO link time optimization whole program. Good luck, you get some random amount of. It's like, yeah, maybe that is an LTO whole program regression. Maybe I should not have added it. I could also check libmet what's going on with that one. Our program of fast PGO. What's going on here? Also, I think I looked into that, and I mean, we had the case that actually, to be honest, wait a second. Oh, is it libmet? No, to be honest, this might actually be. Wait a second. It's only a tiny little bit slower. But this is the thing, right? You spend so many instruction cycles and time and nerves implementing all this stuff. Some stuff is faster and some stuff simply not. Simply to the other day where we found that here version, here this O first native, this was like version 3 or so. Yeah, similar to where yesterday we in general found like version 3 here for GCC is somehow regressing. This is also, it's consistent here, right? So it's not even that much slower. It's just unfortunate that for using AVX, what would it be? AVX 1 and 2, I guess. With GCC on Sen 3 might be slower in some cases. So that is not even, you would think on first glance, also it's a little bit, yeah, with Klang in between there, but I mean, maybe next I should probably do that with Klang, potentially. Do they have PGO? Anyway, at the end, too much random stuff. The more exotic optimization stuff, the more unpredictable the results at times. I wish that would be a little bit more consistent. I wish this would be a little bit easier to use. At least we improved our open source benchmarking a tiny little bit. I probably, it's a hack, right? Again, if you look at this code, it's just like tiny little stuff I've done for the Linux magazine 15 years ago. I improved this, polished this a little bit more. Also, like, polished this by adding random profiling features, making the source a little bit less readable because, and this still could be improved, right? Currently, I reconfigure, which is not ideal, but usually works. Doesn't take the most time, but probably we should not do that. So this profiling theoretically, although I worked it into there, it could be a little bit better off configure, make profile run, make clean, make of a little bit more integrated stuff. But at least I optimized the benchmarking stuff here of, I commit this in a second. Yeah, at least I optimized some profiling stuff that it doesn't take forever and some other cleanups and stuff. But yeah, just benchmark stuff a little bit. At the end of the day, you partially rewrite your open bench stuff for results. Anyway, leaving the comments what you think. I think as per yesterday, I settled for O1, O faster stuff for our smartest optimization. Somehow, I also, in my personal, as I said, my personal getaway here is, my personal takeaway here is that somehow I would wish with the millions of, I said this yesterday, right? In total, of course, nobody paid millions, but like with the all employees' salary at Red Hat, SUSE, IBM, and all the other code sources, who potentially Facebook or wherever they have been working. Of course, there were a handful of compiler engineers working on this for years. So of course, it easily, this feature as a whole in GCC costed some companies, and with that humankind in the economy, easily millions. And for $1 million feature, in my opinion, the results leave a little bit to be desired, to be honest. But maybe that is a common thing with projects written in C, because everything is so difficult that at the end, years later, it's like, yeah, but being so busy handling parsing files and handling strings, I don't know. Anyway, so yeah, that's it for this video. And also last but not least, it's not easily usable for cross builds and also not for the Linux kernel, right? For the Linux kernel, because obviously you can't just run the Linux kernel like this, right? So I would even need to look in how they would do that, if they have special data log writing to use PGO. I think there is some profile guide optimization for Linux kernel, or yeah, I would need to look into that, because obviously the Linux kernel is not a normal program where you can link libgconf. Maybe they have their own libgconf data storage implementation then, or something like that. So for the Linux kernel, also not directly, in case you're wondering, not directly usable. I think there is something, leave in the comments below. PGO might yield even better results with insane L3 cache. I thought I have quite insane L3 cache. What do I have in total on this Ryzen? 72 max, I think, right? Of total L1, L2, L3 caches combined. But yeah, there are always stuff with. But I mean, in general, I think the code should profit a little bit more. I mean, sure, this code is already optimized a heck for years, so new generations of GCC, recurring theme here, not that much. I mean, what should be there? It's a glorified assembler. See the glorified portable assembler from it, right? What more do you want to optimize there except tree vectorize, automated vectorization? What I should probably benchmark also is automated threading, not only as AMD, but I think there is in the meantime some automated OpenMP for offloading huge loops for multi-threads or something. I probably should, but yeah. Anyway, you know, distributed system design. Yes, I do. I need some tips. You need to be more specific, but we will do some more microkernel, because I'm mostly done with benchmarking for this year, and also for the future. You probably want to share, like, subscribe, now that I have a little bit more infrastructure, a little bit more clean code that I can more easily run, like in the future, like a new GCC, just like run this, benchmark all stuff, have the chart, and make a more proper video. The more you share, like, and subscribe, Patreon and YouTube membership and all the good stuff, the more time I can spend on this. And over the weekend, and this obviously already multiple hours burnt on benchmarking. I found some win-wins. Previous video, right? LTO needs full program, and OS mostly too slow for us to just use. So for T2, some amazing win-wins there. Also otherwise, yeah. Anyway, leave me below what you think, what do you use, what are your tips, and otherwise, or if you are a GCC developer or other compiler engineer, leave your comments and stuff below. Otherwise, I hope you learned something. Have a good day, and see you next time for all the next low-level and IT stuff fun to come.